Okay, today we're going to talk about proportions in triangles, section 7.5. So I hope you remember what a proportion is. We'll look at it in a second here. Okay, so theorem 7.4 is the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So copy the diagram and the theorem down and come on back to the video. Okay, so if a line, we're talking about RS here, is parallel to one side, in this case parallel to XY, and it intersects both sides, then it divides those sides proportionally. So in other words, if RS is parallel to XY, then XR over RQ is proportional to YS over SQ. So that's the side splitter theorem. A parallel line to one of the two sides or three sides of a triangle splits the other sides into proportional pieces. All right, let's try a problem with this. So what is the value of X? We know here that KL and PN are parallel, and KL bisects the sides of the triangle. So setting up my proportion, 12 over x plus 1 is proportional to 9 over x. I could have also written x plus 1 over 12 is proportional to x over 9. When we do the cross product of either of these, we will get the same values. So I'm going to stick with the first way that I did it. Again, it really doesn't matter as long as you're doing the same portion. If you start with 12 over x plus 1, you have to do 9 over x. So cross product, 12 times x equals 9 times x plus 1. Don't forget, when you're multiplying by a binomial, you have to distribute. So 12x equals 9x plus 9. Subtracting 9x, 3x equals 9. Come on. And x equals 3. Okay, so our proportion then ends up being 12 is to 4 as 9 is to 3. Okay, so there's an example of that. Now, a corollary of the side splitter theorem says that if three parallel lines intersect two transversals, so kind of like a triangle be intersected, but it's three parallel lines and two transversals, then the segments intercepted on the transversals are proportional. So A is parallel to B is parallel to C. Therefore, AB over BC is proportional to WX over XY. Same idea, except we don't have a triangle. Okay, we've got just two transversals. I'm not going to do an example of this one. We're going to go ahead and do our last theorem. It's going to be a pretty quick video. So our last theorem is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, that's my ray, AD, then it divides the opposite side, whoops, that should be one word, into two segments that are proportional to the other two sides of the triangle. So again, write that down, write the diagram down. So if AD, that's my ray, bisects angle CAB, then CD is proportional to DB as CA is proportional to AB. Divides the opposite side into two segments that are proportional to the other two sides of the triangle. And let's do one with this. So here's my diagram. I'm going to, since PQ bisects this angle, this is proportional to this. QS is proportional to RQ, as SP is proportional to RP. So QS, 18 is proportional to 10, as X is proportional to 12. I get 10x equals 216, 18 times 12, 10 times x, so x is 21.6. And that's the entire video. We got to keep track of these relationships. Remember, you will get your theorems, but you need to be familiar with them so that you don't have to go hunting every single time you're looking for a proportion. All right.